So this is going to be the last presentation for today, so I'll try to, so I think it's cancelled, yeah, yours is cancelled. So I'll try to make it fast. So today we're going to talk about SDN based network automation and open standards. So this is going to have a couple of topics, some general principles of SDN. Then I'll present some SDN, Juniper SDN solutions. Then we'll talk about fusion. And then we'll talk about open standards and what we do with our SDN-based solutions. So I'll start with the SDN principles. So, we are pure play network vendor, right? So we are not just a cloud company like VMware. So our vision is to connect everyone, to provide network everywhere, empower everyone, yeah? So we have SDN in several pillars. So data center, core, edge, WAN, campus, access and integration for both enterprises and service providers, yeah? So what is SDN? SDN is in general control and management tools that provides technology for faster service deployments. Yeah? And many people are mixing this with network function visualization. Yeah? Network function visualization is something different. Yeah? So network function visualization is the technology that allows to deploy applications on very fast range on virtual machines, yeah, so that these applications can be controlled centrally, provide centralized control plane, centralized management of the systems and the software, and leave the data plane on the silicon, on the hardware. Yeah? So we have a portfolio of network function virtualization products. Yeah, some of these were addressed today. So Firefly, our virtual SRX. We have virtual MX. We have virtualized analytics. We have service control gateway in a virtualized fashion. So we have also a lot of third-party partnerships, even competitors of ours. For example, we have Checkpoint also running in a virtualized fashion on our Contrail. Yeah? So going further on, general principles of SDN. Yeah? So there are a couple of very critical things that have to be addressed here. So the main concepts are separation of control plane and data plane, centralizing the control plane in terms of routing, centralizing the management in terms of management, network function virtualization and applications, yeah, and distribution of the data plane. So data plane has to remain there where it is switched and routed on a very fast scale, namely on the routers directly in silicon. Yeah? The other thing is then key architectural thing is then the domain independent and domain dependent knowledge how we should build and deploy applications on these platforms. Yeah? Automation is another thing that has to be mentioned. Automation in terms of deploying applications, deploying services, things like layer 2, layer 3 service provisioning and analytics. Yeah, so these are the main things that we're addressing. Yeah? So in the next couple of slides, I will show you a couple of Juniper SDN evolves solutions in the different sectors. So we'll start with data center. I think this was already addressed today several times, but it's about virtualized data center. Yeah? Hot topics like virtualization, cloud, big data, SDN are driving strategic IT conversations and investments. Yeah? So what is changing in the data center? It is scalability, time to deploy, cost, services, right? So how we deliver these things for our customers through automation and orchestration. These are several things like JunoSpace, OpenStack, cooperation with VMware, with Microsoft for orchestration, space for FCAPS management and application configuration, etc. Yeah. So this is yeah. So what is the difference? What makes Juniper unique? Yeah. So we have a vision for software-defined networking and for the data center. So and this is then namely how we deploy this virtualization. So it is like an overlay network. And we're using our technology like MetaFabric, QFabric. So we support also VXLAN for VMware. So we can terminate VXLAN and make also the connection to VLAN. So things like automatical VLAN provisioning. So this is something that is unique. Yeah. VNFs at the edge. So we are utilizing the existing, in many cases there is existing MX infrastructure. So based on this infrastructure, we can deploy services at the edge, close to the users. Doesn't matter if this is a mobile subscriber, if it's a fixed subscriber, or it's a kind of let's say, a cooperative subscriber, which is some kind of layer 2 or layer 3 VPN terminated. Yeah. So service control gateway provides subscriber awareness, and based on this subscriber awareness, we can push service chaining. So for particular subscribers, based on their profiles, we can attach services. And those services are running at the edge. They are not really running somewhere at the premises of the customer. So this is why we can provide concepts, something like a virtual CPE, where you don't have to have firewall or caching engine or deep packet inspection engine on the customer premises. All these things are running at the edge on the MX and also on x86 servers. Yeah? Further on, traffic engineering. This is a very critical thing. So we have a solution that is called Nordstar. So this is our controller that is utilizing a PCP protocol. It is actually kind of a LSP management tool that provides visibility of the network architecture and how the network is built. And based on information that is coming from the BGP LU or for some other network matrix, so we can take intelligent decisions on the fly. So we can do path diversity, for example. We can have redundant paths that are taking different physical paths. Yeah. We can play with the RSVP. We can also do application-specific routing. So based on some new protocol that is running on top, CSPF protocol, Juniper proprietary. We can take, for example, one or the other part to route data traffic towards two endpoints. Yeah? Unified wired and wireless. So we have a piece of software that is running on Juno Space, so-called the SPOG, a single point of glass. Yeah. So this single point of glass provides a unified presentation and workflow. So it's a kind of a role task-based application that is providing an overview of the network. Yeah. So with this single point of glass, so you can do things like zero-touch provisioning. So you can do rapid deployments. Practically, is a snapshot of the network from one central location. So I have also a snapshot of the graphical user interface also in place. Yeah. Access and aggregation. Yeah. We have deployed virtual MX. So virtual MX is nothing else like Junos running on x86. Yeah. So in many cases, actually, why we do this? Yeah. So we are addressing the gap of small routers. So up to 10 gigs, there is not real Juniper router that can serve a certain amount of data, so low end. For that reason, virtual MX is filling the gap, and For cases like access aggregation, the virtual MX is really interesting thing, yeah? Either for mobile backhaul or for small cases connecting enterprises, this is ideal, yeah? We're managing this virtual MX also with Contrail and OpenStack, and we are providing on top of that the Northstar controller, yeah? So this Northstar controller, as I mentioned, is doing the traffic engineering, yeah? For the WAN connections. So we can also connect two data centers and manage the connectivity between, yeah? So we have also Juno Space, last but not least, that is doing the FCAPS and the service provisioning, yeah? And all these things are running together, so they're all connected. There is the dynamicity in Northstar, also connected with Juno Space. We have the orchestration layer running on top of that with Contrail or any other orchestration systems, yeah? In general, Contrail is providing an open API so that we can use any orchestration systems, yeah? By default, Contrail is coming with OpenStack, but you can use anything else, yeah? So even you can also connect to an existing umbrella management system, yeah? Another thing, software-defined security. It was mentioned today. We have several things. So Firefly, which is also our virtual SRX. We have the Web App Secure, our web virtual security solution for web resources protection. We have DDoS Secure, which is also a virtual DDoS protection solution, which is protecting enterprise networks and data centers against attacks, yeah. We have also done our analytics product as well for security information, events correlation, etc., etc., yeah. So next I will talk about Fusion, our tool for automation and network simplification. So what is Juno's Fusion? It is kind of a model that allows subordinate elements to delegate functionality through a supervisor or controller, yeah. Practically, you can imagine a central place, MX router, which is taking configuration information from, let's say, Juno Space or Northstar or any umbrella management system, and is pushing configuration information towards X amount of network elements in the system, yeah. So these network elements could be Juniper, but that could be also proprietary, so third-party products as well. So the only thing that we require is netconf or YANG interface, yeah? So we can do configuration management, we can do CLI commands, we can do alarm management, false performance, QoS, packet forwarding, so all these related things to packet flows, yeah? And as a controller, we can use MX, or we can use any external MX. So our story is naturally with Northstar, but it could be anything else, yeah? So in terms of scale, so this device can manage up to thousands or more than thousands devices as one management interface, yeah? It reduces the provisioning by thousands because you just provision to one device, you don't provision thousands, yeah? You touch different network layers. It uses netconf and YANG, and it manages not only Juniper, it manages also third-party systems, yeah? Could be an optical system, it could be some mobile case or cable, and it is extended to SDN. So how it looks like, yeah? So we have the MX as an entry point, and through the MX, so we send configuration information to endpoint devices, yeah? One typical example is for mobile operators who have microwave. So we have several implementations in place with some microwave vendors, but also then we have cases where we manage cable modems as well. So for example, we have bad weather conditions. So there is a rain, storm, whatever, and the microwave is kind of not really adjusted, yeah? So automatically we get information about the microwave signal, that the signal is going down. And based on that, we can send configuration information, for example, to the cell side, adjusting the QoS correspondingly, so that we have bigger buffers and we expect jitter, etc., on the line. Yeah. So automatically, once the weather gets better, so we can dynamically adjust the buffers back to the normal. Yeah. Or another example where we manage, for example, the cable modem connection. Yeah. So a typical broadband case where a subscriber buys a new package correspondingly, so interface speed and QoS has to be adapted. So on the internal side, on the MX side, we send a configuration towards the CP, and also then on the virtual interface, automatically this configuration is in place. Yeah. The benefits of Fusion. So operational simplification first. Yeah. So we have just a single point of control. We reduce the complexity, cost. Yeah. It's a kind of a centralized client-server model. Yeah. And yeah, we use this really efficient, and we deploy it on massive scale. So there is no limitation in terms of performance and in terms of different interface complexity. So there is just one single interface integration. That's all. It's done through netconf YANG interface. So currently, if you know Juniper Node Unifier, so the current version of Fusion is building on top of JNU, but we're extending the JNU, so we put also then netconf on top of that. So currently it's DMI interface only, yeah? And in case we manage non-Junos devices, so we require some YANG compiler to be available so that we can push the corresponding schema to the subordinate device, or any endpoint. Yeah. Further on, some other solution that is kind of involving, or let's say, it is part of our overall SDN architecture. This is the Nordstar 1 controller, and is also connected to the Fusion. So it is a kind of a server-client model where Nordstar is playing the orchestration role and is pushing netconf interface towards the network elements. Yeah? So as I mentioned, Nordstar is using PCP by default, but sometimes the devices cannot really speak PCP because this is a piece of software client that is not native for every device, right? And in case this is not available, netconf YANG is the alternative way to send configuration to a device, yeah? And in this case, Nordstar is playing the role as controller, as a single configuration touch point, yeah? So my next slides are talking about open software and open minds. I will not talk about in detail about Contrail, assuming that most of you know what Contrail is. But I have some comparison of our simplest MPLS architecture mapped to Contrail. Yeah. So on the top of on the right hand side of the slide, you see it and the simplest MPLS architecture, having access aggregation core, and we have end-to-end services. So on each and every hop of the network, so we do BGP label exchange. Yeah. So compared to Contrail, so Contrail in fact is a system virtualization networking system that is using similar protocols. Yeah. So it is playing, well, let's say the main concept of Contrail is utilizing virtual router. Yeah. Virtual router is nothing else than a router. Yeah. So it's just using open software, right? And this virtual router is using BGP to exchange packets, and is using XMPP. Yeah. So XMPP is used whenever we exchange routing information towards the controller, and BGP is used whenever we talk to the gateway function of the network. Yeah. Mapped to MPLS, again, we're using BGP, so there is nothing third party here, nothing that is not according to standards. Simple BGP, XMPP is open IP protocol, nothing different. Yeah. Then the virtual machines on which the virtual router is running. So these are considered as a custom edge devices to the MPLS concept. Yeah. So there is no need for some routing protocol because communication between virtual machine that is running in the virtual router is happening through the kernel of the machine. Yeah. And if it is like external communication, this is again the control plane is going through the controller, is XMPP. And if it is going to some external device, let's say physical firewall, it is again so BGP based. Yeah. So we're running a tunnel for the data plane in Contrail, which is a GRE tunnel, and within this tunnel we again send BGP. Yeah. Again, nothing proprietary. So this is known functionality. So GRE is in the IT world since maybe 20, 30 years. Yeah. So far for Contrail and the protocols mapped to IP MPLS architecture. Yeah. Nordstar, the other solution that I've mentioned, is using PCP. So PCP is again RFC protocol that is also not proprietary. Netconf and Young are again open IT protocols which are also standardized. Yeah. So between the controller, Nordstar as such, and the network, we're using BGP. Again, open protocols, nothing hidden, nothing, no secrets. Another solutions that we have in the program and also kind of fitting into our virtualization story, this is Wandle. Wandle is, or let's say the application that is most used in Wandle, this is IP MPLS view. This is a multi-protocol, multi-vendor, multi-layer traffic management solutions for traffic analysis. Okay? It is reading information from the network by doing show commands, or it's reading information from the BGP, or let's say ISS or OSPF databases, and based on that is providing topology, network topology. Yeah? So with Wandle you can do very interesting things. For example, what if scenarios. Yeah? What will happen in the network if a specific fiber is not available? What if a router in the network is failing? What if I have some bottlenecks in the network so that all my traffic is sent through some link that is, let's say, oversubscribed? Yeah? So these things are really interesting and really valuable. And we're extending the Wandle, so we're putting the Wandle into the big SDN picture, combining the Wandle with Nordstar, so we can export, for example, the network picture that is collected through Nordstar, put it in Wandle and do what-if scenarios and do network traffic optimization or traffic engineering. Yeah? Further on, or let's say my last slide for today is openness. Yeah? Some key message to you. Juniper is not trying to lock the customers. Yeah? So with our SDN solutions, so we are playing openly. Yeah? So we are trying to be fair players, so fair game. Yeah? So as you saw, there are no proprietary protocols in our SDN story. Yeah? So the investment that our customers are making is not really tied to some specific technology or some specific hardware. Yeah? We are members of the IETF and NETSI, and we kind of participate in these standardization bodies and contribute in specifying and standardizing protocols and solutions. Yeah. We have also our Open Lab. Open Lab is a place that makes possible to do interoperability tests, to deploy and test SDN solutions and trying to prove on the market specific concepts. Yeah. We're also providing SDKs to the world, available for integration, available for customization. So I welcome you to take a look at the Juniper Developer Network, the so-called JDN, where we connect developers by providing open APIs for further development and integration. Yeah. Open Daylight is another platform that we propose to contribute elements specifically in the terms of XMPP. So XMPP is a key element, let's say protocol into our SDN story. And by this Open Daylight, we are actually opening the interface and providing flexible data models to extend our SDN solutions.